Haptic interfaces build on the idea of making human-computer interactions as natural as possible. Your first experience with haptics was probably your phone vibrating in your pocket, or maybe it was the rumble pack on your N64 controller. But whatever the case may be, you probably don't know it as a haptic interface. Haptic interfaces are interfaces that can create an experience of touch by applying forces, vibrations, and motions to the user. Any sort of information received through touch is haptic. Braille could be considered haptic communication, but as it appears in technology, it's generally either tactile or kinesthetic. Haptic interfaces can be grouped into three main types: graspable, wearable, and touchable. For graspable, think joysticks. One clear application is in the operation of robotics, so that an operator can feel how much resistance the robot is pushing against. Graspable interfaces take advantage of kinesthetic sensations, feelings of movement, position, and force mediated by nerves, not just in our skin, but also in our muscles, tendons, and joints. Wearable haptic interfaces, on the other hand, usually rely on tactile sensations, such as pressure, friction, or temperature, that are mediated by nerves in the skin. A variety of experimental devices are worn on the finger, pressing against the finger pad. The final category of devices are touchable interfaces, such as smartphone screens that might create a sensation, for example, a little bump when you click on an app. Now let's look at different kinds of sensations or haptics that haptic interfaces are capable of producing. So they can provide tactile feedback, meaning that they can provide sensations of vibration or pressure on the person. For this, the person is sometimes wearing a jacket. For example, it could be wearing a wearable haptic interface, such as a jacket that's embedded with actuators. So actuators are different from sensors in the sense that sensors measure changes in a certain variable, whereas haptics are able to apply force on the human body. So a haptic jacket can, for example, enable a user to experience every interaction with their environment. The other kind of sensation that haptic interfaces are able to produce is called a vibrotactile feedback, which is more than a sensation of pressure or vibration. It feels more like a sense of touch. It's going at a deeper level, going from skin to underneath our skeletons, our bones, trying to tap into our deeper nerves. The third kind of haptic interface is known as the ultrahaptic. The third type of feedback that haptic interfaces can produce is called ultrahaptic. In ultrahaptic interfaces, ultrasound beams can be used to create localized senses of pressure on a finger without touching any physical object. The focal point that creates a sensation of pressure is generated by individually controlling the phase and intensity of each transducer. Some of the uses of tactile interfaces or haptic interfaces could include to nudge the user to do something. So for example, if a user is not playing violin correctly, then they can experience sensations that forcing them to correct themselves. Same idea can be applied to any other situation. For example, in a learning situation, if the user is, for example, is not doing their exercise movement properly, then they can be nudged with haptic interfaces to correct their movements. There are a lot of interesting research and design considerations of haptic interfaces. First of all, we have to decide where to best place the actuators on the body, and at which place the actuator is going to be more effective in terms of producing the kind of behavior we want to induce in the user. Secondly, we have to decide the manner of the haptic. What kind of feeling do we want to generate? Is it going to be just accomplished through one single touch or sequence of touches? and how intense is that touch or feeling going to be. And then we also have to think about whether the user, it will be acceptable for the user. In what context is a haptic sensation going to be acceptable to the user, and in what context it won't be acceptable. And then we have to think of creative ways of using the vibrotactile interfaces that already exist in smartphone and smartwatches. For example, a single vibration can indicate a rain, and a successive vibrations can indicate a thunderstorm.